It was the winter of 1901. In the grand halls of Stockholm, where knowledge is celebrated like royalty, kings and queens gathered. Scientists held their breath. The Nobel Prize in Chemistry, for the first time in history, was about to be awarded. And the honor went to a Dutchman. A quiet, thoughtful man rises to receive the very first Nobel Prize in Chemistry. A man who saw chemistry not just as reactions and test tubes, but as the invisible dance of molecules. This is the story of Jacobus Henricus van Hoff, the dreamer who gave structure to science. Jacobus Henricus van Hoff was born on August 30, 1852, in Rotterdam, Netherlands. He was the third of 7 children. His father, Jacobus Henricus van Hoff Sr., was a physician, a man of precision and intellect. His mother, Alida Kolff, came from a refined Dutch family. She fostered in young Jacobus a love for poetry, music, and art. Young van Hoff was brilliant, but unconventional. At school he cared little for rules and routines. He was often caught daydreaming during lessons, imagining the shape and motion of atoms. He began his formal studies at Leiden University in 1869, but soon transferred to Delft Polytechnic School to pursue chemical engineering. His thirst for knowledge knew no boundaries. He studied at the University of Bonn under Friedrich Kekulé, and later at Paris's École de Médecine under Charles Adolphe Wurtz. In 1874, he earned his doctorate at Utrecht University, at just 22 years old. In 1874, Van Hoff published a paper that would change chemistry forever. At a time when most chemists thought molecules were flat, he proposed that the carbon atom formed bonds in 3-dimensional space, arranged in a tetrahedron. This idea laid the foundation for stereochemistry, the chemistry of spatial arrangement, which explains why some molecules with the same atoms behave completely differently. Van Hoff didn't stop at molecular geometry. He sought to understand how reactions worked on a larger scale, how temperature, pressure, and concentration affected chemical equilibrium. He introduced what would become known as Van Hoff's law, showing that the equilibrium of a chemical reaction changes predictably with temperature. This principle is fundamental in physical chemistry and engineering. One of Van Hoff's greatest breakthroughs was in understanding osmotic pressure, the force that draws water through a semi-permeable membrane. He discovered that solutions followed the same gas laws that applied to ideal gases, a revolutionary insight that unified chemistry and biology. In 1901, Alfred Nobel's vision took form to honor those who conferred the greatest benefit to mankind. And the first Nobel Prize in Chemistry was awarded to Van Hoff. Van Hoff moved to Berlin in 1896. There he joined the Prussian Academy of Sciences and became a professor at the University of Berlin. Though quiet and introverted, his lectures were profound. His books, like Studies in Chemical Dynamics, were translated across Europe. He inspired a generation of scientists who would carry chemistry into the 20th century. Van Hoff didn't seek glory. He sought truth. He supported the ion theory of Arrhenius and worked alongside titans like Mendeleev and Ostwald. He showed the world that chemistry wasn't guesswork. It was a mathematical science. Jacobus married Johanna Mies in 1878. They had 4 children. Despite his fame, he remained a humble family man. Quiet, contemplative, always curious. He wrote poetry, played music, and loved the beauty of nature, finding in it the same harmony he sought in molecules. He was a scientist, yes, but also a mystic. He believed that beauty and truth were intertwined, and that science at its core was a reflection of the divine. In his later years, Van Hoff turned to geological chemistry, studying how salts crystallized in nature, trying to understand the chemistry of oceans and rocks. His curiosity never faded. He believed science and art were not separate, but two faces of the same truth. Even in his final decade, Van Hoff remained a seeker, applying chemical laws to nature itself, proving that chemistry didn't just exist in flasks, but in oceans, rocks and stars. On March 1, 1911, Jacobus Henricus van Hoff died of tuberculosis in Berlin. He was 58, but his legacy would outlive even the Nobel itself. Every chemistry student studying equilibrium, every doctor using osmotic pressure, every scientist modeling molecules in 3D, they all trace their knowledge back to Van Hoff. He didn't just revolutionize chemistry, he gave it dimension, direction and depth. More than a century later, his ideas still burn bright, lighting the path for those who dare to imagine more. He was once a boy who saw shapes in the clouds. He became a man who saw order in chaos, and in doing so, Jacobus Henricus van Hoff etched his name in the annals of science forever.
Thanks for being with Awards. Subscribe to know more about international award winners and unsung heroes behind peace, science, and humanity.